AI in games can be such a mess. It walks into the walls, not sees the player right in front of it, and just ignores their comrades getting obliterated in front of them. Is it really that hard to make AI do what it's supposed to do? Everyone has probably encountered AI that just breaks the immersion. It's okay if it makes you laugh. But it's so fucking frustrating when you get stuck in a mission because this son of a bitch can't enter the bloody door. In this video, I'll show you what causes AI in-game to behave like idiots. I have recreated some AI screw-ups to show you what's happening under the hood and how many things you need to consider to make it good. Let's meet the cast. We have a werewolf and sheep. The werewolf's behavior is gonna involve finding the sheep and making them suffer. We're gonna start very simple. Step 1, find a sheep. Step 2, walk up to it. Step 3, attack. And to make it clear, we wanna avoid this. So we want to make sure werewolf attacks the sheep when he's close enough. And to program this logic, I'm going to use what's called a behavior tree. Think of it as I'm programming AI's brain. The point of a behavior tree is to constantly provide an answer to a question, what should AI do now? In a behavior tree, you make and add nodes and combine them together, and that creates the logic. And for our 3-step goal, we need to do this. But we need to connect it with a node that would say, do these in order. And that node is called sequence. So let's connect them all and see what happens. It worked. Kinda. We never told him to stop, so he keeps repeating the same thing. Our first issue, we don't consider a certain scenario like, don't fucking attack a dead body. It's essentially the same thing here. The mice stuck in a loop. However, before I fix that issue, I want to bring your attention to that we avoid doing this. But how? There is one important thing to know about each node in a behavior tree. Every node wants to succeed or fail, to become green or red. Let's take this little guy as an example. He only has one job, make our AI move where we tell it to. And if it manages to do that, it's gonna be green, if not, red. That's why the attack only happens after we have approached the sheep. So the little guy is doing his job, moving the werewolf, so it's neither green or red. Yet. It's pretty much stuck in there until it has made up its mind. And please remember this, nodes can be stuck when determining the color. We're gonna return to this later. But I just said every node wants to be either green or red. What about this sequence node? And it's actually the same thing here. For a sequence node to be green, it needs to have all the nodes that are connected under it to be green. I hope you got all of that. No? Then it doesn't matter, we're moving on. Let's go back to our bug where the werewolf keeps attacking the dead sheep. We can fix that by changing the logic from finding a sheep to find an alive sheep. And boom, he stops doing anything when there are no sheep, just like we wanted. And if I was to add more sheep, it seems to work pretty well. The keyword, seems. We actually never fixed our problem, we just hid it. And I'm talking about this problem. Our werewolf is still stuck. It's just before he was constantly stuck in a success loop. Now he's just a constant failure. Because it cannot find an alive sheep. We can move the problem again if, for example, we're gonna move one of the sheep like this. So he's able to find an alive sheep, but he cannot reach it. And this is one of the common issues with AI. We need to consider all of the outcomes. And of course, we can do it how it's done in Yandere Simulator, where the developer just adds if statements for every single thing. So we could do same, like, can't find an alive sheep, do something else. Found a sheep but can't approach it, do another thing. But we don't want to do that. It's stupid. Instead, we have this sequence now, and we know, if it failed, one of the nodes under it had failed before. We don't care which one. We just know it did. So then, we have to do something else. But how? How can we add logic to do something else instead? And that's where another important node comes in. Selector. And to explain how this node works, I'll just show you this example. Here, we have our werewolf who wants to escape the maze. And he's gonna go forward, and if he cannot, he's gonna rotate 90 degrees. And that's pretty much exactly what the node does. Basically, it will check its first connected node if it's green or red. If it's green, the selector will also be green and it's done. Otherwise, it'll go to the next node for the same check. And it'll keep doing it until it checked all the nodes under it or found a node that turned green. And now, you can start to see the pattern in how behavior trees work. Basically, the top node is asking, are we succeeding or failing? Are we green or red? And for him to find it out, it goes down. And that applies for the nodes that I've explained to you, sequence and selectors. They do exactly the same thing. And once the node has decided to be green or red, it goes up. And that's all. There are no more secrets when it comes to behavior trees for you. Also, watch this. You can combine those nodes to each other. Let's expand our previous logic, shall we? Now the werewolf will kill all the sheep he can and then go back home. Let's say this block is gonna be his home for now. And boom, we made our AI a little smarter by considering one more case. Not because the werewolf suddenly got smarter, but because we gave him a plan B. And that's the difference between good and bad AI. Good AI always has a plan B. When you see AIs being dumb in games, that means the developers have not considered this specific situation. And now I'm getting tired of the scenery, so let's change it. Let me present you a village where we're gonna work now. And obviously, because it looks this good, it's not my work. I just took it from a marketplace. And now we're gonna make it a bit more interesting. We're gonna make it so the sheep hide inside houses and they keep the doors locked. But the werewolf doesn't care about the locked doors. He's a werewolf after all. He's gonna just smash them. And I gotta complain about something. It took me way too much fucking time to make these doors break the way I wanted them to. They would explode on the impact, get pulverized, all other stupid stuff. Just not very simple, turn into planks and fall down on the ground. That's all I needed. Okay, back to AI. So our new AI logic is gonna be like this. Find a house, move to the door, break the door, find the sheep, approach the sheep, kill all the sheep inside, repeat. Let's build that up using what we already know. And we're gonna need two sequences for that. The first one is gonna be doing the same thing that we already done, finding and attacking the sheep. And the second one is pretty much the same, just for doors. So we combine these two sequences with a selector on top, so the logic reads like this. If you fail to approach a sheep, find a door instead. And the werewolf will fail to approach the sheep if there is a door blocking the navigation. Which brings us to another very annoying part about AI, navigation. You can clearly see that this village isn't just a flat level anymore. So now we have to deal with a lot of different collisions of the houses, stairs, wall, planks, and all that shit. And that's why AI can pretty much get stuck anywhere. There is literally too much shit. And let's roll back a little. I told you to remember that a node can be stuck while it's deciding to be green or red. And that's what happens here. AI just keeps going. Navigation tells him, oh, you can do it, but in reality there's a fucking door. And in a big game where the world is packed with objects, AI will be stuck somewhere at some point. You can imagine it's very time consuming to go every little rock to ensure navigation will not backstab us later. To make my life a little easier, I disabled a lot of detailed collisions on the assets you see and use simple big boxes instead. And it's because the AI is way less likely to misbehave on simple shapes like boxes. And you know what's the funny part that can cause potential issues? Those boxes are invisible in the game. So we have potentially made a whole new kind of problem, invisible obstacles. The player can see nice stairs, but the AI is actually walking on an invisible cube. And if that cube is placed somewhat wrong, the AI can't get stuck on something the player can't even see, so it looks even more stupid. Alright, let's move away from the navigation. It honestly deserves a video on its own with how annoying that shit is. But now back to AI logic. I think we need to give our sheep some chance for survival. To do that, let's meet our new character. Our knight in shining armor, a guard. Or should I say, guards. They're gonna be protecting the sheep from the scary werewolf. So now I want to show you the problems with introducing different AIs that are supposed to interact with each other. Let's start from the beginning. How will the guards protect the sheep? Obviously, they're gonna attack the werewolf, but it's kinda boring. Let's make them so they patrol the areas, like going from door to door, and instead of just knowing where the werewolf is, they need to see him first. And for that, I also made it so when a door is broken or a sheep is killed, it makes noise the guards can react to. And all that brings us to the last part of the behavior tree that I'm going to teach you today. Decorators. Basically, it's a thing you add on other nodes, like our pink ones or selectors or sequences. And they work like if statements. So for example, do A if you hear noise, do B if you don't. And this is very useful, because now we program the logic like this. If the guard haven't heard anything, he's patrolling, otherwise he's investigating the noise. Now I want to see some action. Let's go through our logic. So, while guards patrolling the streets, the werewolf breaks doors, kills the sheep, and all of that makes noise, so the guards will go investigate. They see the werewolf and both of them will fight. And I actually also wanted to make it so that when the werewolf is low on health, he will go and try to heal instead. And he's gonna heal by killing sheep. Some health bars for visualization and we're ready to roll. And as you can see here, there are already problems. It works, all the behaviors do what they're supposed to, so there are no bugs on that regard. The logic is doing what it's supposed to. But there are other issues. Both werewolves and guards make each other stuck, the guards don't work together at all, and the werewolf will just stop fighting if he's low health and he's surrounded because he's stuck. And now, imagine the werewolf was a player. Do you think you would enjoy if all enemies would just gang up on you at once and attack you without any coordination? I don't think so. I think you would just get overwhelmed. And that's where AI stops being a programming issue and becomes a design issue. And this exact problem happens even in the recent titles. Look here, This is Vampire the Masquerade Bloodlines 2. It was released just a couple months ago. In the game, you play a vampire, and as a vampire, you can suck blood of your enemies to restore some health. And that's what I decided to do here. And the problem is, the enemies don't give a damn that I'm performing a long-ass animation to restore some health, so they keep attacking. And I end up with lower health because I tried to restore some health. And that's where games like Dishonored show a lot of contrast in their AI. Their AI coordinates, waits for you, makes it fun for you, as AI in a good game should. In Dishonored, when you perform a killing move or fighting multiple enemies, it still feels like you're in control. The enemies give you enough space to actually play the game, but make it tense and dangerous, but not unfair. So yeah, it's not about logic, it's about how much AI was considered in its development. Making AI in games is genuinely hard. That's why in my projects, there's no AI, there are only disappointments. Because getting AI right isn't just writing logic, it's everything around it. The design of the game, its rules, the player's options, the level layout, navigation, collisions, interactions, fuck me, too much. And I'm most definitely forgetting something. Even in our tiny example, where Werewolf just hunts the sheep and a couple of guards patrolling and reacting to Werewolf's actions, the number of things that can go wrong, the things that we need to consider, is ridiculous. And when one piece breaks or gets forgotten, the AI doesn't just look slightly off, it looks stupid, and it's all about considering all of the possibilities. Now, here we have it. You've seen some issues that arise when making AI. So next time when you see AI get stuck in your game, you might actually even know why exactly it happens. But I'm not trying to say it's impossible to make good AI. No, not at all. Even in this video, Dishonored is an example. It just takes a lot of considerations and work. And for me, for a person who mostly plays single-player games, AI has always been a very cool part of all the games I played. Like companions or enemies, doesn't matter. And that's why I wanted to explain to you how behavior trees work. And also hint that behavior trees alone won't suffice for more complex AI. If you only rely on one system, you're gonna end up like Bloodlines 2. Sure, AI does what it's supposed to, but it's not fun at all. But when you go deeper and utilize and create more tools like it's done in Dishonored, that's where you're gonna be able to create real immersion. And for now, thank you very much for listening to my ramble. I'm gonna keep making videos about game dev problems, design breakdowns, and stories from my own experiences such as working with designers, the game dev school I attended, and all the dumb decisions that happened along the way. Next time, we're looking at a game that's a buggy mess basically finished by the fans, and still one of the best games ever. Subscribe if you don't want to miss it. Peace.